Hi, myself Siddharth Kulkarni. Today, me and my teammate Adarsh Bhalera are going to present our topic on wind energy, that is Agentic AI framework for maintenance and monitoring of windmill. And this is for the DevCoast Hackathon, AWS Agentic AI Global Hackathon. So coming towards the problem statement and solution, what are the problems? Let's discuss them first. The first is that there is a lot of manual inspection of wind turbines, which is time consuming and also risky for maintenance teams, right? So how we are bringing out the solution is we have trained a YOLO V8 model, which detects defects in real time by reducing the manual effort. We can simply add this use case into drone or sort of sensing cameras, and we can automatically do the predictive maintenance part. Then the maintenance teams lack quick access to technical support or documents. This is the second problem. How we are tackling this is we are preparing a chatbot which can provide quick instant answers using AWS Bedrock and open source knowledge base. And you can get answers with respect to components of windmill, with respect to general FAQs, and also with respect to some maintenance details. And then third problem is that the scaling inception workloads for multiple turbines is complex and also resource intensive, right? So in this case, how we are bringing up solution is we are using cloud native architecture of AWS, which I'll be explaining in the architecture diagram. So next thing is the technical architecture diagram. In this technical architecture diagram, if we go through this, we can see we have users who will be using our Streamlit application, and in this Streamlit application we basically have these kind of agents. So the first agent is the turbine or blade defect detection agent, and the second agent is windmill defect detection agent. So to these agents we'll be giving our image as an input, and these agents we have trained using YOLO V8 model, and the data set was open source. We took the open source data, annotated it, and then we trained it using, so this is the pipeline. We annotated it using label.me. Then we have used Kaggle's GPU environment to train these particular models. Then these particular models, we have dumped them into S3 along with the inference script. Then from S3, we are picking these models, and then we are creating an Amazon SageMaker endpoint for these particular models so that we can use it as an agent. Then the next step is regarding the chatbot use case. So this was the vision use case. Next one is the NLP use case. So here we are actually helping the users and admin to get answers with respect to FAQs, components, and maintenance part. So we have this agent, and then these agents are being actually connected to knowledge base, and the knowledge base is open search over here. So we have the three CSVs for the three particular use cases, and then we index them into open search via S3 script. And then the thing is we also have to maintain the logs. So we are using Amazon CloudWatch logs to in order to actually log the metrics. So this was all about the complete architecture diagram. So next step is the demo part. I have already shared the GitHub repository, and we have not deployed this application since it's cloud-based applications and we have limited cost involved, so we are not deploying it. But anyways, we are recording this video. And coming towards the future scope can be there can be a unified chatbot, okay, which can interact with image, audio, as well as text. Right now, these image and the chat components are separate, but later in chat also you can upload some sort of audio or you can upload some sort of image and then chat with it. Next thing is the predictive maintenance analysis, that we can predict the component failure using historical data itself. The third one is the drone integration. We can use this YOLO models and interact and make them such interactive that we can integrate them with drone, and then we can do the real-time detection and predictions as well. And the next one is multimodal AI fusion. We can also use thermal imaging and vibration sensors, and then we can use this for monitoring the health of that particular windmill. This is our GitHub repository. We have included all the three use cases along with the CSVs and datasets over here, along with the SageMaker deployment scripts, and also the Streamlit app.py script. So this is all about our repository. You can just go through this. Now coming towards the AWS part, these are the S3 buckets where we are actually storing our data. These are the two endpoints which were deployed for the vision use cases. One is the turbine damage detector, another one is windmill damage detector. In agents, we have prepared these four agents for components, Q&A, intent classifier, and maintenance agent. And if we go to one of the agents, which is we have used this Cloud 3.3 Sonnet. Here is the particular role for that. So this is kind of prompt, and the memory is enabled, and this is the knowledge base that is attached. So if we go to the knowledge base over here, in this knowledge base, we can, it is basically open source serverless, and we can see an index has been created. So the index looks like this. So we have the question and answer indexed in form of this. And the dimension of this vector is 1024, and the embedding model uses Titan embedding. So now let's quickly run through the demo part. So this is the Streamlit app that we have prepared. So we have two use cases of computer vision and one of NLP. And let's go to the system architecture, which we have already discussed in another video. These are the agent workflows. Now the first agent is windmill damage detection. So I've given 3 samples to just test it out. So I'll just simply browse one sample. So here we get in this format. This is the actual image. This is the predicted image. Here we can see it is broken. The total detections are 1, image size is this, and these are the metadata information like class, confidence, and the bounding box coordinates, that is top left and bottom right coordinates. And the ID for broken is 1, for non-broken is 0. So this was all about the agent 1, that is windmill damage detection. Agent 2 is kind of turbine damage detection, where I'll again have given 3 images. So I'll open this image over here, and I'll detect it. So here we can see that there was actually a corroded part over here, which was kind of defect, and it correctly predicted over here. So again the same, we got the damage, confidence, and the bounding box coordinates for this. Now coming towards the third agent, which has nested agents. So we have total 3 agents, which we have already seen for the chatbot purpose. This is kind of FAQ chatbot. Now we'll simply start the conversation. So now we have also given few questions which you can test over here. For example, I'll give this question. So it gave us proper answer. Now maybe I can select some kind of general Q&A like what is wind energy and how does wind turbines work. So it gives answers in this way. And if in this way you can just chat with a chatbot, you can also access the history from over here, and then you can just simply go back to chat, and you can also see which knowledge base was used to answer this particular question. Now if I want to end this conversation, I'll simply type exit, and once I type exit, it says thank you for chatting with us, have a nice day, and we can simply download the conversation. So this is how the conversation looks like. For this agent 1 and 2, since it's a vision use case, we have deployed this model onto SageMaker. And this agent 3 is kind of conversational bot, which has been using Bedrock AWS agents and knowledge base as open source knowledge base. So that was it all about the demo. Thank you.